Okay guys, now we're going to start our unit on analytic trig, and we're going to start on pages 6 through 8, which is talking about simplifying and verifying trig identities. Okay, for this we're going to use our unit circle, and we're also going to use this section of our formula chart right here. Okay, so you're going to look at the tangent cotangent identities, the reciprocal identities, and the Pythagorean identities. So those three sets of identities are what we're going to work with to begin our unit. As we progress, we'll use more of these formulas, but for now our focus is going to be on those three. Okay guys, so starting our unit on simplifying and verifying trig identities, we're opening up with this question that says, use the fact that secant u is -3/2 and tangent u is greater than 0 to find the other 6 trig functions. Okay, so this is actually something we've done before. You might remember when we would draw our coordinates and then draw a triangle on there to help us solve a problem. Well, in this case, they've told us that the secant of u is -3/2, and that means that the secant is r over x. So I can match these up and say that r is going to be 3 and x is going to be -2. Now the negative always goes with that x because we're not going to be able to ever have an r value that's negative. So if I start drawing this, we're going to say, hey, I know that x is negative, r is positive, and my tangent is also supposed to be a positive number, is greater than 0, right? So tangent is equal to x over y, and if this is positive, then both of these numbers actually need to be negative, right? This is negative. That way it cancels out the negative on that x. So I'm going to draw my triangle, and it's going to end up in quadrant 3, okay? And we will use Pythagorean theorem to help us solve this for the y value, okay? So if we set up our Pythagorean theorem, we can solve for y, right? We'll have -2 squared plus y squared is 3 squared, okay? And we'll solve this out. We should get 4 plus y squared equals 9, and y should equal 5, right? So y squared is 5, and then we get y equals square root 5. And since I'm in quadrant 3, I know this is negative, okay? Once I've gotten all of these, I can use those to come up with what the other trig ratios are that we don't know. So starting off with maybe sine of u. Well, sine is y over r. And so my y value is -√5, and my r value was 3. And so we can then plug those numbers in, right? Cosine of u is going to be x over r, and we get -2/3. Tangent is going to be y over x, or sorry, x over y. And we have 2/√5. Both of those are negative. Now, those negatives will cancel each other out, and we're going to have to make sure that we rationalize this. So we're going to multiply by √5 on top and bottom, and I'm going to get 2 square root 5 over 5 for my tangent. So 2 more left that we don't know. We've already gotten the secant, so that one's free, okay? And we're going to do cotangent of u, which is just y over x. And so instead, it's just like the tangent flipped over. So we've got square root 5 negative over -2, or just √5 over 2. And the last one that we don't know, the cosecant, is going to be r over y. So we've got 3 over -square root 5. And again, we need to rationalize this. We always want our answers in the simplest forms. So we've got √5 on top and bottom. And we're going to get 3 square root 5 over 5. And it is negative all over, okay? So these are my other 5 remaining trig ratios. And you can see that all we did was plug in those numbers to get that, okay? This is mostly a throwback to what we've already done before. Okay, so let's look at problem 2. Now this is really starting something new. This is where we're going to use that formula chart, and all of this stuff is going to come together, okay? So we see simplify the statement. It says sine x cosine squared x minus sine x. So I'm not really sure where to start, but they've given us a nice hint here, and it says make factoring your friend. So in order to factor, we need to figure out what's common between these, and then we will separate it out. So the thing that I see common here is the sine x's. So I'm going to divide that away. So each piece I'm going to take out a sine x. So now that sine x is separated, I've got this cosine squared still in the first term, and minus, I took that sine x out of here, and I'm just going to have a 1 left over. Okay, so at least I've managed to separate the sines and cosines. Let's go ahead and try to continue breaking this down. Now, the hint also asks us, hey, what does it mean to simplify? Well, I want to be able to get things to combine and maybe become smaller. And that would probably be a simplified version, okay? So we're going to use one of the formulas from our chart here. And there is one formula that uses cosine squared, all right? So there's a Pythagorean identity. And it says sine squared x plus cosine squared x equals 1. And my kind of alert for that, why did I know to use that, was because of this squared, okay? So when I see squares, Pythagorean identities kind of jump out at me because those are the ones that have squares in them, okay? So I see cosine squared x minus 1. Let's see if we can at least get something similar looking out of our identity here, okay? So what I'm going to do is I'm going to say, let's go ahead and get this cosine by itself for a second. Sine squared x, subtract sine squared x, and I've got cosine squared x equals 1 minus sine squared x. Now this might be enough for me just to plug this in here, but we can take it actually a step further and move this 1 back to the other side. And you're going to see it's going to match up perfectly with what I already know. So if I plug this in, I'm going to say cosine squared x minus 1 is equal to sine squared x. So I'll take this section and we're going to replace it with sine squared of x. And that is still being multiplied by this sine x on the outside. And now I'm like, wait, can I combine those two together? They're all sines. So finally, when I put this together, I'm going to have sine cubed of x. And this is my most simplified form, okay? My goal is to end up usually with just one term. One term is my goal. So sometimes you'll have something a little more complex than this, but usually when you simplify, you should try to end up with just one single term. All right, so this next question asks us to simplify again, but this time it says I want everything in terms of cotangent. So my final answer should have no trig functions other than cotangent. So we see cosecant squared x minus cotangent x minus 3. And then we ask ourselves, wait a minute, how can I solve this, right? Let's look at our hint. Our hint says, how is cosecant related to cotangent? So go to your chart and find an identity that uses both cosecant and cotangent. Hopefully, if you look at that chart for a moment, you should find that 1 plus the cotangent squared is equal to the cosecant squared of x. Now, using this identity, we can say that, hey, let me replace the cosecant squared in my function with 1 plus cotangent squared. It's all about just replacing pieces with other pieces that will fit that mold, okay? So I'm going to go ahead and write this out. 1 plus cotangent squared x minus cotangent x minus 3, okay? So what we've done is, again, this section that I'm going to underline in red, we replaced from that cosecant squared x. Now, how can I simplify this further? Are there any like terms that we can combine? Let's start by combining this 1 and this minus 3. We got minus 2. And just writing everything out in a nice order here. Tangent x. Now, everything's in terms of cotangent, except I've got this square, and I'm not a huge fan of that. I'm wondering if I can take it a little bit further than this. Okay, well, this reminds me of a function that might look like this. X minus 2. So I switched all these cotangent squareds and cotangents, and I just said, well, let's pretend like they're the letter x. What could I do with this function to break it down further? I can actually factor this, and if I factor it, I'm going to get something very similar to what we did. So remember, we're replacing cotangent with just x, okay? And if I factor this, I should get x minus 2 and x plus 1. Okay, so this is factoring, right? It's just a quadratic, and I've rewritten it. Now, my final step, I'm going to re-change these back into what I knew them to be. It was cotangent x minus 2, and my other side will be cotangent x plus 1. Okay? And that will be my final simplified form. Now, up here, when we had everything in terms of cotangents, that's okay, but much better that we have it factored out. Okay, so next question says to simplify into a single trig function. So I, again, want to end up with only one term as my final answer. And they've given us a hint again, and it says, hey, rewrite everything, or rewrite the expression in terms of cosines and sines, okay? So what I'm going to do is I'm going to try and rewrite all the pieces that are not sines and cosines into sines and cosines. So the only piece I see here that's not a sine or a cosine is this cotangent. So let's see if we can find a replacement for that using our formula chart. So let's rewrite the problem. And go ahead and go to your formula chart and see if you can find a function or a formula that will replace this cotangent, that is a sine or a cosine. So if you look at your formula chart, under that tangent and cotangent identities section, you should find that the cotangent is equal to the sine divided by the cosine, okay? And they use the letter theta or x or t or whatever you want. As long as we use the same one, we're in good shape. So let's replace this cotangent with sine t over cosine t times cosine t, bringing this one down, and then, of course, plus sine t. Okay, and now let's see if anything cancels out or can be combined together. So the first thing I'm seeing here is actually these two cosines. I've got one out here and one at the bottom. These are going to cancel each other out. And now I've got this sine t plus sine t. What am I going to get from there? There's 1, 2 sines, and so this is not squared, guys. Watch out. Some people like to write squared here, but it's 2 sine of t. Okay, t is just the angle there. All right, so this technique where we use all sines and cosines, right, rewriting the expression in terms of cosine and sine, is a very common strategy. And sometimes it'll make your function a little bit messier first, but you'll look for something to cancel out or combine together, and then it will make the function easier to work on from there, okay? Imagine it's like you're looking for something in your backpack, you can't find it, so you dump your whole backpack out. It's a little bit messy, but eventually you'll find what you're looking for. Okay, on to a problem with some fractions in it. We see sine over 1 plus cosine over sine. Okay, so now in order to add these fractions together, we need common denominators, just like they mentioned in the hint again, right? They said we need common denominators. So what we can do now is we're going to multiply each side by the other side's denominator. So I'm going to write this kind of spread out so I have some room to work. And I'm going to start by taking the sine theta over here, and I'm going to multiply it to the left side. So we've got sine theta on top and bottom. We've got to do top and bottom, guys. Can't ever only do one side. So over here, I'm going to look at the top, and I'm going to get sine squared of theta. Okay, and on bottom, I'm not going to combine these even. I'm just going to leave them as separate pieces for now. 1 plus cosine theta times sine theta. Because you know what? It may be that I want to combine them at the end, but sometimes things cancel out. So I'm going to wait on the denominator to simplify at the end. Okay, so let's look at the right-hand side. I'm going to take this piece, 1 plus cosine, and I'm going to multiply it to the right-hand side, top and bottom. 1 plus cosine theta and 1 plus cosine theta. So watch out. This is going to distribute. Got to be careful to distribute this. And 1 times cosine is going to give me cosine theta plus cosine times cosine is cosine squared theta. Okay, and underneath here, I'm going to have the same thing I have on the left-hand side. Sine theta times 1 plus cosine theta. Okay, and let's see what's happening now, right? These were both added together. Let's see if there's something we can get when we make it a single fraction. So I'm going to rewrite this all as one fraction. Sine squared theta plus cosine theta plus cosine squared theta. And on bottom, I still have that same thing, right? 1 plus cosine theta times sine theta. Okay. Now, is there anything I can do with this to make it simpler? Because right now, it still looks very messy. It looks like we haven't really even simplified this. Well, I'm noticing something. I see these that are marked as being squares. And on my formula chart, I had a section that is dedicated to these squared identities, which is called the Pythagorean identities. Okay, so let's look at the Pythagorean identities, and you should find this identity again. The one that says sine squared plus cosine squared is equal to 1. Okay, so I see a sine squared and a cosine squared here, and they're being added together. So I can say those two are actually just going to make a 1. Okay, so sine squared and cosine squared became a 1. I also have this cosine plus cosine. And underneath, I'm just going to leave whatever I've got here. 1 plus cosine theta times sine theta. Awesome. Now let's see if there's something else we can do here. I noticed that, hey, look, a 1 plus cosine at the bottom and a 1 plus cosine at the top is going to leave me with 1 over sine theta. Whoa, that looks a lot better than what we started with, right? Now we're to a single fraction and it's 1 over sine. And I feel like I'm almost done. I could stop, but there's one extra step, okay? 1 over sine, we can actually make that into our final answer. There's a reciprocal identity that changes this into cosecant theta, okay? 1 over sine is equal to cosecant, okay? So just remember, when you see that 1 over sine, you know to make it into a cosecant. It's much better to have it, all our functions on the top of the fraction rather than the bottom. So I'd rather not leave it in that 1 over sine form. Awesome, let's keep moving and check out this next problem that says rewrite 1 over 1 plus sine theta so that it is not in fraction form. Now watch out, this problem is difficult, okay? What they did was they want you to jump into the conclusion that, hey, I can just use my reciprocal identities and make this into a cosecant. But we really can't do that, okay? 1 plus sine theta, and the problem is that 1 that's at the bottom there, it's going to throw us off if we're not careful, all right? So that is kind of the trap, and what we're going to do is we're going to use the conjugate of the denominator, which means we're going to use the opposite sign. So I'm going to use 1 minus sine theta, and I'm going to multiply this, but not just at the bottom, we've got to do it on the top as well, okay? So when I solve this now, once we've got that, we can start to multiply this together. Now, 1 plus sine theta and 1 minus sine theta are going to make us have to FOIL this out, okay? So once we FOIL this out, we should start getting 1 times 1 is 1. Should have plus sine theta minus sine theta and minus sine squared theta. okay? And on top, 1 times 1 minus sine theta is 1 minus sine theta, okay? So let's continue to try and break this down further. And I'm going to start by seeing that these two middle pieces, the two mid signs here, plus sign and minus sign, are going to cancel each other out. So now I've got 1 minus sine theta over 1 minus sine squared theta. Interesting. Now, good news, we've gotten somewhere, right? We've gotten a simpler looking fraction, but it hasn't gotten out of being a fraction, and I want this to not be a fraction. So what can I do from here? Well, 1 minus sine squared, that one's kind of screaming at me that, look, there's a square here. Let's use a Pythagorean identity, right? So let's take a second and look at our Pythagorean identities chart. Which one uses sine squared? You should come up with sine squared x plus cosine squared x equals 1. And once again, I'm going to rearrange this, right? So if we rearrange this, we're going to end up with sine squared x minus 1 equals negative cosine squared x. And what am I saying here? I'm just saying that I can subtract the 1 and I can subtract the cosine squared x to the other side. And by moving those around, now I've gotten this, right? So this was a Pythagorean identity, and we rearranged it. Okay, so by rearranging it, now I've gotten it to match what's in my equation, right? And again, my red flag for this, how did I know to use this identity, was these squares, right? So I know that once I have a square, I'm going to use a Pythagorean identity most of the time. Okay, so let's plug this in. Let's use this replacement, 1 minus sine theta over negative cosine squared of theta. Okay, and now I'm still a fraction. I want to get it out of being a fraction. So how can I handle this? Well, let's look for an identity that will get rid of this denominator somehow, all right? And we can look for it and find it under our reciprocal identities. What we'll find is secant theta is equal to 1 over cosine theta. So what I can do is, by taking a cosine at the bottom, I can move it to the other side, and then it's going to become a secant instead of the cosine. So what I'm going to do is I'm going to take the section I've got down at the bottom, cosine squared theta negative, and move it to the top, and it's going to become a secant. So we're going to move to the top as a secant. All right, so now I've got 1 minus sine theta times negative secant, and I'm going to bring that squared with it, okay, theta. And that is going to be my non-fractional answer right there, okay? And you could leave this negative out in the front if you wanted to, but we could also have left it the way it is shown right now, okay? Remember, what did we use? We used this, which is a reciprocal identity, okay? So the identities are like formulas. You need to find something that will match the task that you have, match your formula that you're working on, and see if it will simplify somehow, okay? So our goal here was to get it out of being a fraction. We're no longer a fraction. Boom, we're good to go. All right, so one more simplifying problem, and this time they've tried to throw you off, but this problem is actually not very difficult. It says rewrite the natural log of cosecant theta plus the natural log of tangent theta as a single logarithm, and then simplify whatever you get. Well, the first challenge here is these natural logs are here just to confuse you, but realistically, it's not difficult because according to the log rules, if we add two logs together, so if I have log A plus log B, we're just going to say that's the same as log of A times B, okay? So that same rule applies to natural logs. So this statement right here, I can make into natural log of cosecant theta times tangent theta. And by doing so now, we've got it all as a single log. But I still want to simplify this further, okay? So I need to find a way to make these look a little bit nicer, all right? And I'm going to go back to a strategy that we used previously, which was to make everything into sines and cosines. So we're going to use a combination of the reciprocal identities and the tangent and cotangent identities. So let's start with cosecant. Cosecant theta is equal to 1 over sine theta. So I'm going to start with that one. That is a reciprocal identity. Okay. And you can find that on your formula chart. So this will be 1 over sine theta. And the tangent now is going to be equal to sine theta over cosine theta. Okay. And that is using the tangent identity. Okay. So you can find those at the top of that formula chart. So let's replace this as well. This is going to end up being sine theta over cosine theta. And now, like, I can put that multiplication sign. I can bring the rest of this problem just down with it. But very simply, I can immediately kind of jump out and say, wait a minute, these two signs are supposed to cancel each other out. And I'm just left with 1 over cosine theta. And we could use a third identity now, actually, and say, wait, I know that secant theta is equal to 1 over cosine theta, okay? And so I can use this another reciprocal identity to make this into secant theta. And now that I've got that, let's just bring the rest of this problem down. Just say, hey, natural log of the absolute value of secant, and that is my simplified answer. So overall, all we had to do was use the reciprocal identities a couple of times, and it ended up canceling out some sine values, and then we ended up with our final answer, 1 over cosine, which turned into secant. And then it's a single trig function again, and I'm like, wow, that is simpler than what I started with. Okay, so that is the first part, simplifying trig identities. So we're going to learn some different strategies to approach these, but in general, we're going to look for pieces of the formulas that match up with what we're working on, the problem that we have in front of us, and try to plug pieces in so that they cancel out or that they turn into simpler forms, okay? A lot of times, we're going to end up canceling things out with fractions, or we're going to end up combining stuff into higher powers or multiples of each other, okay? Great. Hope you enjoyed the video, guys. We'll see you for the next one when we talk about verifying trig identities.